So we're gonna go over our homework for 5.1, and I'm actually gonna go over every problem just to make sure that you guys got it. The first 4, 5 were super easy. Yep. And then I could see the problem with the word problems, but they're exactly the same as the last couple. So we're gonna start with 20. And you started with x to the fourth minus 3x squared plus 5 over x to the fourth. When you have a fraction, you want to split them up. So x to the fourth over x to the fourth minus 3x squared over x to the fourth plus 5 over x to the fourth. So if you haven't done your homework, you might want to get some paper out and do it. That'd be great. Finish it by reducing it and then doing the antiderivative. X over 4 over x over 4. I'm sorry, x to the fourth over x to the fourth is 1. The next one is going to be 3 over x squared. And then 5 over x to the fourth. Anything higher than the 1 power on the x's, you're going to pull that x to the top. So if it's on the bottom and it's a single x, there's a different antiderivative for that. So again, 1 minus 3x to the negative 2 plus 5x to the negative 4. When we find the antiderivative or we integrate it, you make sure you add a power and then divide by that power. So we have just a singular 1. That's going to give you an x. So remember, the 1 has x to the 0 power, so that means nothing. And then we add 1. I go ahead and just write that negative down. I don't try to do everything all at one time because it gets confusing sometimes. And your 3. Negative 2 plus 1 is negative 1. And then I divide by the negative 1 power. Then we have plus 5. X to the negative 4 plus 1 is negative 3. And then remember, we put a plus c on the end. The last thing you need to do is just clean this up. This equals x. A negative over negative makes a positive 3, and I'm going to move my x to the bottom. 5 over negative 3 makes a negative 5/3. Move your x to the bottom, and then plus c. That is what you should have. I'm going to tell y'all something. I'm real tired of grading like chapter 4 work and chapter 6. Does everybody understand that? Okay. If you don't have 5.2 homework by Monday, it's going to be a 0. Got it? If you don't have 5.1 put in the box today, it's a 0. Because I told you I'm going over every problem. I have some people that had chapter 4 in the box. Dude, we're done with that. We're done with that. You are old enough and smart enough to get your homework done on time, and I'm not doing it again. And I surely am not going back to chapter 5 to do homework. If you didn't do your chapter 4, if you didn't do your chapter 4 homework, other than 4.7 was the only thing I haven't put in yet. And you haven't done your chapter 3, chapter 2, it's done, y'all. I'm not going to keep wasting my time going back because you want a grade. You want that grade, you earn it when you're supposed to. I did. You guys put it in the box and I didn't grade it. So it was the only thing that I should have had in the box to grade for you guys and your test. That's it. And I had lots from chapter 4, like 4.1, 4.2. No, like Eliza's different because she was on quarantine and she had to turn all her stuff in. That's different, y'all. You sit in class every day, you do nothing. I'm not taking your crap anymore. I'm not doing it, y'all. Not doing it. Okay. In college, you don't do your work. Guess what's going to happen? Big fat 0, they don't give a crap. They don't care. You're making extra work for me. You know how long it took me to do this 5.1 homework? 20 minutes last period. 20 minutes. Now, did I slow down when I got to the word problems? Sure. But how much time do you get in class to do this? Sometimes I give you the whole class period, and some of you don't do any work at all. I'm gonna start writing you up, which is really sad for an AP student. Are we clear? I need AP scores. I need AP scores. Now, I know some of you are not even gonna try on that exam. I'm not a dummy because you don't try in class, so it's gonna be the same. But I need those of you that are really willing to try to start working hard. Don't complain when you have a B at the end of this class if you have not done everything that I've asked you to do. I'm tired of giving grades. You need to earn them. This whole speech is not for everybody. So if you're offended by it, it's probably you I'm talking about. If you're not, you're like, I'm doing everything I can. We're good to go. Everybody understand that? I'm not taking your work 4 chapters late. It's not gonna happen. All right, again, 5-1 better be in the box at the end of the period. Does everybody understand that? Paying it forward. I got a million things to get back to you after we finish this. Okay, I graded your 4.7, which I was a little bit disappointed in. I mean, come on, y'all. Come on. The review and the test were exactly the same. They're exactly the same. I'm not sure what's going on. Don't complain. 26. At some point, we need to have a quiz on these. It will probably be after Thanksgiving. We're probably only going to get one more section in, so we'll probably get 5.3 on Monday. I don't know how long 5.3 is. I haven't even done it yet. Okay, so I'll do it 4th period, next period when they take a test, and I'll let you know. I have it typed up. I just don't have it wrote out. When we do this, we want to go ahead and distribute in that secant y, tan y minus secant squared y dy. Both of these have rules. You need to know those integration formulas. That's what I'm telling you. You need to know those. If you know those rules, you know that secant y tan y is secant y. You know that secant squared y is tan y. And then we throw on a plus c. Problem takes about 2 seconds if you know your integration. You don't put that phone up. $30. Was the integration of cosine x? What? Oh, no. Oh, I was reading the problem. You're telling me the answer. Sorry, I was like, what did I do wrong? Cosine x plus 3 to the x. This 3 to the x also has its own integration rule. Okay, so make sure that you read that integration rule. Cosine x is sine x. What's your integration rule for 3 to the x? It's 1 over ln, whatever your a is, times a to the x. And again, that's a rule on your integration rule sheet. So we have plus 1 over ln 3 times 3 to the x, which are random c, and then just clean this up a little bit. So sine x plus 3 to the x over ln 3. Don't forget your plus c.
So if you keep the 1 times. So if you do like the original state,
It shouldn't be, because it's the same, unless they say reduce as much as possible. I think you'll be okay. I would count it. It wouldn't bother me. All right, 38. They gave you f prime of x equals x squared, and they need you to get down to f of x. The way you do that is by plugging in values. This is actually a very easy problem. This one and the next one. So we're at f double prime. To get to f prime, we integrate. What is that? And then it tells you that if you plug in 0 for x, you should get 8. So that's what I'm going to do right here. I should get 8 if I plug in 0 for X. This becomes 0 and doesn't matter. So I get 8 equals C. That goes right up here with this. And to be able to get to f of X, that's what we have to integrate again. So X to the third over 3 plus 8 dx. What is the integration of X to the third over 3? Good. One more power is 4. You put it on the bottom with a 3. 3 times 4 is 12. With the 8, you just add an X. And you put a C. This tells us this is your f of X right here, but I need to find C to make the actual equation. So this tells you to plug it in. If I plug in all of that, if I plug in 0, I'll get 4. So 0 to the 4th over 12 plus 8 times 0 plus C. These cancel out, and I got 4 equals C. So my equation for f of X is X to the 4th over 12 plus 8X plus 4. How long have those problems taken us? See what I'm saying? Okay. The next one is the same way. I gotta flip my paper. All right, 42 gave you f double prime of X is 2 over X squared. F prime of 1 was 4 and f of 1 equals 3. Same exact problem, just a different function. What do I do? I'm going to go ahead and rewrite it. Remember, if it's higher than a 1, put it to the top. What does that give me? Leave your 2. What happens here? You're doing a derivative. And then plus C. So it says when I plug in 1, I'll get 4. This is going to change -2 times 1 to the -1. Remember, we can put that 1 on the bottom, which gives us -2, which gives us that C is 6. So then we're going to integrate, fix this, -2 over X plus 6. When we integrate that, we're going to leave the -2. And how do I integrate 1 over X? ln absolute value of X. And then how do I integrate 6? And I always have to put plus C. To get the C, it says plug in 1, you should get 3. So 3 equals -2 ln absolute value of 1 plus 6 times 1 plus C. -2 ln 1 is, you can't see it, 0. So this cancels out. That gives me 3 equals 6 plus C. So C equals -3. So our function is -2 ln absolute value of X plus 6X minus 3. Right. 53. Gave you a big long word problem about using -32 That's the first thing that you're gonna integrate. There's nothing with it. It's just negative 32, and then they use t for time. What is my integration of that? Not x, but t. Now, if you used x and you wrote dx, that's perfectly fine. Y'all just don't interchange those variables at all. And what else? So remember, in our word problems, we're going to integrate twice. So our c, we're going to put c1 instead of just c. Okay. So then it told you that f of 0 equals 60. It told you that in the word problem. So this says, when I plug in 0, I get 60. So that means that C1 is 60. Rewrite your equation, negative 32, T plus 60. What do you think that I do to that equation? Integrate it. Integrate it. So dt on the end. What is my integration? Just t squared over 2. Keep going. $60t. And then I'm going to label this one C2. Very good. Because it's the second constant. That's all. That's all. I'm going to clean this up. What does it give you? What else did it give you in the problem? What it asked you to do? Somebody set the book open. I don't have my book open. It's back there, and I don't want to do that heavy as crap right now.
Michelle, this might sound stupid.
53.
How do you know, like, how do you know to divide by two?
Right here,
Yeah.
that's the differentiation rule. Remember, we divide by the power.
Oh.
What'd you say?
How high does?
That's what, read it again before it. Just read the whole like sentence. So that's what we're plugging in now. Yep, so we're plugging in, it should give us 6. When we plug in 0. What's that gonna give me? Oh, this is 0, sorry. 6 equals C2, right? Right. So your position function is this one. Position is always that first one, and then you derive to get the velocity and acceleration, okay? So your position function is negative 16t squared plus 60t plus 6. What does it ask you to find, Bryant? Your turn. For the max height, right? So now we use this to find the maximum. How do we find the maximum? Yeah, I would put it in your calculator. I think I already have it in. Yep. So here's your function in the calculator. I did zoom 0 so that I could see the top. Second trace, max, go to the left of the maximum, go to the right, go to the middle. It gives you this coordinate right here, 1.875 and 6225. Remember that this is T, and what does T represent? Time. This F of T is gonna be your height. So my height is 62.25. I don't know if it's feet or whatever. I don't know what the problem said. I just wrote it down. Now, if they asked you how long it took to get to the maximum height, what's our answer? 1.87. What if it asked you how long it took to hit the ground? What would you have to find? One of the x-intercepts, right? What about your initial height? It's gonna be your other x-intercept. So this one would be your initial height. This would be when it hits the ground. Does everybody understand that? And then the maximum height. All right. 54. Good. You're welcome. Okay, just. No, no, no. 54 is pretty much the exact same problem. The only difference is they don't give you a couple other things, but you can still find it. So the steps are going to be the same. Just follow it like this is the hardest question. Okay, this is the hardest one. So the steps are the same. You just have to follow with some extra variables in there. So we're still going to start with the negative 32 dt. What's that going to give us? Hmm. And then we have our plus C1, right? C1 is going to be our initial velocity. Okay, that's what it is all the time. That's where that 60 came from in the last one. It was our initial velocity. Does everybody understand? But they don't give us one this time, so we're going to leave it as V sub O, which stands for initial velocity. So then we're going to integrate our new equation. Which is negative 32t plus our initial velocity. Treat it just like it's a 6. It's fine, a 60, whatever you want to treat it as. What does that give us? And then what about your V sub O? It's going to have a what? T. What else is it going to have? C what? C2. Okay, so same thing, right? Your C2 is your initial speed. Position, whatever you want to call it. Okay. Very good. So this is the formula you're going to have. Negative 16, because negative 32 divided by 2 is negative 16. T squared plus V sub OT plus S sub O. So then you have to use an equation that you've already had. Your equation is your S prime of T. So if this one was double prime, this one is your prime. Does everybody understand that? Okay, so we're going to use that. Equals negative 32t plus V sub O. And we want to equal to 0. Okay, so to go from f prime x to f of x, to get to f of x, you have to differentiate this, and you have to differentiate this to get there. So they do not stand for the same thing, but you have to work one to get to the other. It's like we're going backwards now. All right, so if I solve this, this is gone now because I've set it equal to 0. How do I solve it? Don't stress out. I need to solve it for T.
add the 32.
I told you to solve for T, right? Okay,
Add 32 to this.
no. We're solving for T.
Subtract B sub O.
Add 32 to it.
Yeah. It's same thing. You're doing the same thing. You're doing the same thing. Yes, B sub O, yes. Sorry, y'all. I had it in my head exactly how to do it. Yes, I would add the 32 over and then divide it by, it don't matter, whatever way. So it's gonna come out B sub O over 32. You're gonna take that, and you're gonna put it into this equation right here. Okay. T is V sub O over 32. Squared. Plus V sub O over 32. Your S sub O is 0. Does everybody understand that, where that came from? So I'm not gonna put that on there. Yes, sorry. I was thinking about this part. And then we have a 0 here because the S is 0 right here. What did it tell you that it was gonna be? 550. So now we're gonna work this out. We get -16 times B sub O squared. What is 32 squared? I didn't work all this out on my paper, so 1024 plus B sub O squared over 32. What do I do now? Mhm. I'm gonna actually reduce this. 1024 divided by 16 is 64. So I get a negative B sub O squared over 64. But what you did is right. I just did it all at one time. Plus B sub O squared over 32 equals 550. If I had X over 4 plus X over 3 equals 550, what would I do? A common denominator. What would be my common denominator between these two? 64. So this one is good as is. How do I get from 32 to 64? Multiply by 2. 64. Now I can put those together. What's a negative? Treat this like an X. A negative X squared plus 2X squared. X squared. So we're using B sub O squared over 64 equals 550. What do I do now? Multiply by 64. 550 times 64 is 35,200. Then what would I do? And I get B sub O equals 187.60. So again, having to solve for that B sub O is what makes it a little bit crazy. Okay, so I definitely can understand that one. All right, 64. Everybody good with this one? Got it?
Especially one.
On the next one, we're going to start with cosine T, and we're going to integrate it. And we get Sine T plus C. Your V sub O is 0. So when you plug in 0, you get 0. So our actual function for this is just sine T. We don't have to put the plus 0 on there. What do I do to sine T? Integrate it. What do you get when you integrate it? Plus C. Yeah, this is 1, this is 2. If you guys want to start doing that, that's perfectly fine. And then it gave us x is 0. Then it's going to equal 3. Is everybody good with that? That was in the actual word problem. So it says I'm going to get 3 if I plug in 0. When you plug in negative cosine 0, you get -1, which means that C2 is 4. So what is our function? This is the actual answer. This one, sine T, and this new function that we have. What's our new function? The very last one. Negative cosine T plus 4. So those are your two position functions or whatever that they're looking for. What does B ask you to do? Well, you're using sine T for this. When it's at rest, it's not doing anything. What do we know about a sine curve? Yeah, so it looks like this, right? So if this were your x-axis, you have multiple x-intercepts, right? So multiple times that it equals 0. Those places where it equals 0 is at every pi value, 1 pi, 2 pi, 3 pi, 4 pi. Does everybody understand that? So in general, it would just be k pi. Whatever your k is. And they'll define it like this, k equals 1, oh, sorry, 0, 1, 2, 3, dot, dot, dot. So that's what you'll see on your answer keys if you're looking them up. And that's why. Okay. So, right, good? Any questions? Hello? Okay. All right, you're welcome. The one time she said his name right. It's a good bit different. All right, are you guys good? All right, I'm gonna give you the rest of your 5-2 homework. $2.99, 13, 15, 17, 21, 25, 29, 31, 33, 35. So make sure you copy that down.